This retroactive idea, it has to be that, says Nobel Prize-winning mathematical physicist Sir Roger Penrose, reflecting on a problem about the building blocks of reality that has dogged physics for nearly a century. Any sensible physicist wouldn't be perturbed by this, he adds. However, I'm not a sensible physicist. If Penrose isn't a sensible physicist, it's because the laws of physics aren't making sense, at least not on the subatomic level, where the smallest things in the universe play by different rules than everything we see around us. He has reason to believe this disconnect involves a fissure that divides two different kinds of reality. He also has reason to believe that the physical process that bridges these realities will unlock answers to the physics of consciousness, the mystery of our own existence. Penrose's contributions to math and physics are significant. He's proposed a theory of sequential universes that existed before the Big Bang, traces of which seem to be penetrating ours. He collaborated with Stephen Hawking on the Penrose-Hawking singularity theorems, identifying points in the universe, singularities, where the gravitational forces are so intense that spacetime itself breaks down catastrophically. For decades, Penrose has been working with anesthesiologist Stuart Hameroff on a theory of consciousness called Orchestrated Objective Reduction, Orch OR. Penrose primarily handles the physics of Orch OR, whereas Hameroff handles the biology. Their theory was formulated as a response to serious gaps in established scientific frameworks spanning physics, neuroscience and psychology. All, some or none of the hypotheses in this theory might prove out experimentally. The smallest bits of matter in the universe are quantum particles. Quantum particles exist in multiple possible states at once. This is called a particle's superposition. A wave function is a mathematical term that describes the particle's superposition. A wave function can collapse, causing a particle's many possible states to reduce to a single, fixed state. Wave function collapse is important for reality as we know it. It's because of collapse that when we look at something with our naked eye, we see one thing. In the realm of big things, the world described by classical physics, we don't see one thing as multiple possible things all at once. When scientists measure a particle, it seems to collapse to one fixed state. Yet no one can be sure what's causing collapse, also called reduction of the state. Some scientists and philosophers even think that wave function collapse is an elaborate illusion. This debate is called the measurement problem in quantum mechanics. The measurement problem has led many physicists and philosophers to believe that a conscious observer is somehow acting on quantum particles. One proposal is that a conscious observer causes collapse.